If this is a string and I pulled it from the left corner of the string up, down, and then back again in its original position, it will create a wave and it will look something like this. And it will be traveling in this direction, right? Because it's transferring the energy. Oh, sorry. It will look something like this. So, and after some time, it might look something like this. So the wave traveled all the way to here. And this kind of wave is called the pulse pulse wave, because I only did it once. But what if I did it multiple times? What if I did it twice? So it would look something like this, right? And this type of wave is called the periodic wave. It's called a periodic wave because it's repeating itself after a definite amount of time, right? So it's called a periodic wave, and let's see how the sound wave can be a periodic wave. So this is a sound box once again, and these are the air molecules here. Okay, so after it dissolves one, it vibrates, so it will push the air from this area, and the air will bump into this. So after one cycle of dissolved, it will look something like this, and it's traveling this direction. So after some time, it will be somewhere here, and let's say we vibrate the sound box, where we salt the sound box in each second. So after 1 second, it will be here, and a new compression will be formed here because we did it twice. And let's say after 3 seconds, the first vibrated compression of the air will be here. This will be the second one, and this will be the third one. It's creating a periodic wave. And if we plot a graph here of the density of the air, so it will look something like this. So it's highly dense, so I'll plot it in a higher place, and all of a sudden it's low here, it's again high here, low, highly dense. So if we plot the graph, it will look something like this. Although this is a transverse wave and this is a compressed wave or a longitudinal wave, these two things looks completely different, yet they are the same, of the same notion, right? So now I want to show you how this periodic thing works. So if someone asks you that how what is the distance between the normal and the what it's called, the maximum height, it's called peak. These places are called the peaks, and these are the trough. So if someone asks you that what's the height between the normal and the peak, well, it's the amplitude. It's called the amplitude. And I wanna ask you two questions. The first one will be, how many seconds per cycle? And the second one will be, how many cycles per seconds? Okay, so see, these are the complete opposite questions. So the first question is how many seconds per cycle. So after each cycle, that means after this, each time I did it up, down, and then back again in its original position, what's the time required after this? So how many seconds does it take per each cycle? Well, that's just the period. That's called the period. That's just the time interval, and it's denoted with a T. The unit is seconds. And the second question is how many cycles per second. That means in each second, how many times can I do this up, down, and then back again? Maybe it's 20, like in each second I did it 20 times. It can be. So, and this is called the frequency. It's called the frequency. It's denoted with an F, and the unit is hertz. So notice here that these two things are the complete opposite questions. And it makes sense because they're the inversions of each other, the period and frequency. So the period will be the invergence of the frequency, and the frequency will be the invergence of a period. So if I tell you that I can make in each second I can make 20 cycles, so the frequency will be 20, then the period or the time taken for each cycle will be 1/20 of a second. Hope this helped you. See you in the next video.